dear learners, welcome to this session. So in this session I am going to discuss about the electrical power system basics. So after going through this session you will learn about the some basics of the electrical power system. You will understand how the electrical power is generated, and you can explain about the power transmission system. You can also describe about the power distribution system and various problems related to the generation, transmission and distribution, and you will know about the grid. So learners, in India the electrical supply is generally AC, or we can say alternating current, which work on the AC current or voltage, and it is available at many different voltage levels depending upon the ease of use or technical requirements. So you can use both AC power or DC, but generally the AC is more popular. So the lowest voltage level, the retail consumer gets the electrical power at 230 volt, and this is the single phase 2 wire supply. You all aware about this? And so barring this single phase supply and some occasional high voltage DC lines, all other supply in are the, you can say, 3 wire 3 phase. So the line voltage stated in these cases is always the voltage between any 2 phases. So now I am going to discuss about the various voltage levels, like the 400 volt. Generally these are the standard values, like 400 volt, 3.3 kilovolt, 6.6 kilovolt, 11 kilovolt, 33 kilovolt, 66 kilovolt, 110 kilovolt, then 132 kilovolt, 220 kilovolt, 400 kilovolt. So you have heard about all these kind of voltage level when we use about the power transmission and power distribution. So there is no hard and fast rule that what should be the voltage level for the transmission network and what should be the voltage of the distribution system. But generally the voltage level 132 kilovolt and above are the part of the transmission network. That means the high voltage are considered for the transmission of power supply. Why? I will tell you later. Then lower voltage levels are used in the distribution system. So these are the power generation, power transmission, power distribution. These are the basic 3 components of electrical power system. So here I am showing you the typical electrical power supply system, where you can see that how the power is being generated at the plant and then it is being transmitted up to the consumer end. So through various stages. So electrical power supply comprising the generating units that produce the electricity, then after high voltage transmission lines that transport the electricity over the long distances, then low voltage distribution lines are there that delivers the electricity to the consumers. Then you also know about the substations are there. Substations which are the part of the electrical power transmission and distribution system, where the voltage are transformed to the lower levels for distributing power to the end users. This is transmitted at very high voltages. Why? Because it reduces the losses. So if I talk about the different component of the power this power system or power transmission and distribution system, so you can see here that the grid substation, the various voltage, these can be categorized into the various voltage level, like grid substation, sub-transmission system, then power sub-transmission system you can say here, then power primary distribution feeders can be there, then distribution substations, secondary distribution network. So when we talk that grid substation, so power from the transmission network is delivered to the sub-transmission network after stepping down to the voltage to 66 kV or 33 kV through the 220, 132 or 33 or 33 kV substations. So, you will come to know about all this thing later, that how this is being happening one by one. Then that means the power is being generated at some voltage, suppose 11 kilovolt, and the transmission is done at very high voltages, and then up to the distribution you have to reduce these voltages, because at the distribution end the voltage is kept low, that is the 400 volt or 220 volt single phase supply, which is coming to the consumer end or at your home or various industry or hospitals. It can be the 3-phase supply, it can be the single phase supply. So, this constitute the complete network of the power system. So, now the sub-transmission system, where the network power is carried at the 66 to 33 kilovolt by the overhead lines and by underground cables. So, distribution substation power is further stepped down to by the 11 by 0.4 kV transformers. What are these transformers? You all are aware of it. A transformer is used for the either for as a step up transformer or step down transformer. That means the voltage is can be step up from one level to another level, or it can be step down from one voltage level to the another voltage level for the utilization purpose. So, this transformer is a very essential equipment for all this power transmission and distribution system. So, let me discuss about the power generation. So, if we say that what are the major player in the power generation in India. So, in India we have the central utilities such as the National Thermal Power Corporation, National Hydro Power Corporation, Nuclear Power Corporation, Damodar Valley Corporation, and many more. So, these are the which are basically involved in the generation of the power. Then state electricity boards, which are the state owned utilities, like you can say the Odisha, Haryana, AP or Uttar Pradesh, Karnataka. So, they also involve in the generation of the power. Then there can be the licensees such as the BSES, CESC, or there can be the independent power producers or projects can be there. When we talk about the power generation, then you know that the power can be generated in the thermal station, in the hydroelectric stations, nuclear electric stations, or diesel stations, or gas turbine plants. So, or we can say stations, or we can say plants. So, there are various plants based on the source, the fuel we use to produce the electricity. So, based on that the fuel, the name of the plant is there, like thermal stations where the coal is used to produce the electricity. So, there are various sources of energy which can be used to produce the electrical power, and so these we can say that power this comes from the renewable or non-renewable sources. If we say the non-renewable sources are the conventional energy sources. That conventional energy sources you can say you can obtain from the fossil fuels like the coal, oil, natural gas. So, if you use it more, it can deplete. So, you all know about this, that to reduce the mitigation or mitigate from mitigating the carbon to the atmosphere, and to or emitting of the carbon in the atmosphere. So, for the reduction of it, or there are some other major concern like the to save the environment and for the energy security. So, now the renewable energy sources are being very popular, and this can work as a alternative for the this conventional energy sources. So, why we are using renewable energy sources? Because these can be replenished, and conventional sources can deplete. So, what are these renewable energy sources? Like the solar, biomass, wind, tidal. So these sources or these are in abundant, these are available in the nature. So these can also be used to produce electrical power. So various other electrical sources which are very common, the conventional sources are, they can be the solid fuels, they can be the liquid fuels, they can be the natural gas or hydro, or they can be the nuclear. Different kind of techniques are used. In the coal, the steam is produced using the fuel, and this steam runs the turbine, and this turbine gives the mechanical energy. Then this mechanical energy converted into the electrical energy by using the generator. So like this, the various in the various process, these plants generate the electrical power. Similarly, in the hydropower plant also, the head of the water, it is used to run the turbine, and then turbine's mechanical power is converted into the electrical power by using the generator. There are some other energy forms. If I discuss that, the wind. So it is used near the coastal areas and where the very high wind possibilities. So the wind plants can be there. We have seen the wind turbine. So this is the renewable energy source which can produce the electrical power, and thermal conversion is also possible, like using the solar collector. That means that the heat energy received from the sun is collected, and this can be converted into the electrical form, electrical energy by using the thermal conversion. Sunlight is used to heat the water, and steam is produced. Steam run the turbine, and then after that mechanical energy is converted into the electrical energy by using the generator. Then photovoltaic conversion is also there. PV, you have seen lot of photovoltaic panel in just near you at a rooftop photovoltaic plants, or you have seen the different we can say PV modules. So these modules or solar power plant are there. So these solar power converted directly into the electricity by using these photovoltaic panels. They have the property, solar cells are there. These cells, what they do, the sunlight is incident on the panel, and it is converted into the electricity. Then tidal waves are used to run the turbine for generation. Similarly, the fuel cells are also where without combustion the electricity can be produced. Biogas, the gas produced by the breakdown of the organic matter in the absence of the oxygen. So this can also be used for produce the electricity. The chemical reaction, the chemical energy, this can be converted into the electrical energy, like in the batteries, primary cells or the storage cells. So like for example, the dry cells you have seen here, that there is the chemical energy converted into the electrical energy, nickel, cadmium, lead acid. So in our country, the national electric grid in India has the installed capacity of almost 370 gigawatt in December 19. So the share of installed generation capacity from energy sources is being shown here, like coal, large hydro. The percentage from the coal is 55%, 55.5%, large hydro 12.3%, small hydro 1.3%, wind power is sharing the generation of 10.2% in India, solar power 9.3%, biomass 2.7% at present, and nuclear 1.8%. So these the gas is 6.7%, diesel 0.1%. So these are the contribution of the various energy sources in the power generation. So learners, now we are going to discuss about the power transmission. So in India, the power plants produce the 50 cycle per second. This is the frequency which is measured in hertz, and alternating and the voltages between the 11 kilovolt and 25 kilovolt. So the electric power is brought from the power plant or generating power plant to the consumer through an extensive transmission and distribution system comprising the transmission lines, it may have the distribution networks, or forming the state and regional grid. Grid is the interconnections of the various lines. So, the various stages for the power transmission. At the power plant, the 3-phase voltage is generated and stepped up to the higher voltage for the cross country transmission. Basically on the cables are strung on the towers. So, the high voltage and the extra high voltage transmission in the next stage to transport the this AC power from the power plant over the long distance at voltage like 132 kilovolt, 220 kilovolt, 400 kilovolt, 760 kilovolt. So, for the longer distance and higher powers, higher voltages are economical, you can say. Yes, by using high voltages there is reduction in the line losses. So, in special cases you will come to know that high voltage direct current transmission 500 kV DC is also preferred some cases, but in normal cases generally the high voltage AC transmission is there. So, sub transmission network at 132 kV, 110 kV or 66 kV or 33 kV, so constitutes the next link towards the end user. So, some major player in the power transmission are you can say the like most of the states reconstructed their state electricity boards and have unbundled them in 3 entities: generation, transmission and distribution. So, you know that the at the time of the independence that state electricity boards, they was the one utility which was handling all the things: generation, transmission and distribution. Later the reforms came and then unbundling have been made, and then the 3 entities: generation, transmission and distribution. Central sector company like Power Grid Corporation of India Limited, which is also called PGCIL, is the owner of most of the higher voltage transmission lines in the country. A few private sectors also like Tata Power, Reliance Power have also been entered in this field now. You can say that this power distribution segments involve receipt of bulk power from the transmitting utilities and the supply of the final consumers at lower voltage level. Distribution, like after the transmission you have to distribute it to the consumer. They can be the major consumer or they can be the low level consumer which consume the power at small level. So, distribution at generally made at that 11 kilovolt, 6.6 kilovolt, 3.3 kilovolt. So, this constitute the last link to the consumers, which is connected directly or through step down transformers. You have seen the substations are with this kind of voltage level. So, these transformers which are used in the substation bring the voltage level down to the 400 volt for the 3 phase or 3 wire, 4 wire, 3 or 4 wire secondary distribution. The 4th wire is generally present is called the neutral or return wire. So, you have seen that the so I will discuss it about this in a later stage, that how this is being happen. So, the single phase residential lighting loads is connected between any one phase or and neutral, which is of 230 volt, and if there is a 3 phase load, then it is connected across the 3 phase line directly. So, here this is the typical electric power supply system with distribution network. So, I am showing it here, that which is giving you a broad idea about that how the power is being transmitted, and from the various towers are being shown here. Then at various voltage levels, then step by step this this high transmission is there, high voltage transmission is there, then different substations are there. At distribution substation, this voltage is being reduced and then it is reaching to the consumers by using the feeders or distribution network, and up to the end consumers. They can be the for our the house consumer or industrial consumer, so and can be the commercial consumer. So this layout will give you some idea about what is the power transmission and distribution network. So now I am going to discuss about this. So the power distribution system, if we discuss, then we can say that electricity generated by a power station is carried over a transmission line at very high voltage, as I have discussed earlier also. So usually these lines may run up to the hundreds of kilometers and deliver the power into the common transmission network, that is called grid. So this grid is connected to the load centers through a sub transmission network of usually 33 kV, or sometimes it can be the 66 kV lines. So these lines terminate into the 33 kV or 66 kV substations, where the voltage is stepped down to the 11 kV for the power distribution to the load points through a distribution network of lines at 11 kilovolt or lower. So this is from transmission to distribution, how the voltage is being reduced using the substations and transformers. So the power network concerned to the end user is distribution network of 11 kilovolt line or feeder downstream to the we can say the feeders downstream of 33 kV substations. So each of 11 kV feeder which emanates from the 33 kV substation branch further into the several subsidiary, you can say the 11 kV feeders to carry the power close to the load points. So at these load points, a transformer further reduce the voltage from 11 kV to 400 kV. There are some consumer which want to utilize the power at 400 kV, like the household applications. We use the power in 230 volt single phase supply, or three phase supply also can be used for the big consumer. So now our aim is to convert the power to convert the voltage from 11 kV to 400 kV to provide the last mile connecting or last mile connections through the 400 volt feeder, which is called the low tension feeders, LT feeders, which is very popular name. So just in the brief, what are the advantages of the DC transmission and what are the disadvantages of the DC transmission? So if we say that DC transmission, the advantages is that it require only two conductors and there is no problem of the inductance and capacitance. So the lesser voltage drop for the same load and sending end voltage, then one kind of effect you have heard or not, the skin effect or lesser no skin effect will be there, which generally comes in the case of the AC when you deal with the alternating current. Then corona loss is also when you deal with the AC current. So lesser interference with the communication circuit. Generation is at high DC voltages is difficult. So and the second major disadvantage is that we cannot use transformer. That means that DC transformers are not available. AC transmission advantage is that the high AC voltages can easily be generated and AC voltages can easily be stepped up or stepped down. So as the AC voltages increases, the transmission loss decreases. Some disadvantage can be with the AC transmission is that existence of the inductance and capacitance. And this because some reactive power is losses are there. So presence of skin effect and more than two conductors are required. When you say the power distribution, you have heard the word of feeder. So this feeder could be either of overhead lines or it can be the underground cables. Then in urban areas, owing to the high density of the consumer, the length of the 11 kV feeder may be generally up to the 3 kilometer. That means we have to reduce the length of the feeder in the urban areas. And in other hand, in the rural areas, the feeder length is much larger. It is up to the 20 kilometer. So then a 400 volt feeder should normally be restricted to the that means if you are using the low voltage feeder, 400 volt feeder means low voltage feeder. So it is restricted to the 0.5 to 1 kilometer only. That means it is advisable that it should not be run over the long distances. So this unduly long feeders lead to the low voltage at the consumer end. That means the losses are there. So some measures are like reduction of the aggregate technical and commercial losses. Then it is necessary to improve the customer service. Then increase the revenue collections. Yes, the theft is there and the power pilferage is there generally in the rural areas where the I have just mentioned this. Adopt better management in the distribution sector and use of the information technology. Yes, because you have to keep watch on all the consumers and continuously, because the supply is there and demand is continuously increasing. So to so at various places the different kind of technology is being used, information technology. By using this these kind of technology, you can make the efficient power distribution system, or you can lot of challenges or the problems you can address by this. So the major some problems I am just stating here, that with the generation, transmission and the distribution system. If we talk about the generation, then there can be in some places inadequate power generation capacity. So inadequate power generation capacity may cause is one of the problem. Then lack of optimum utilization of existing generation capacity. If the power plant is there or generation is there, but it is not being utilized proper, so this is also one of the problem with the generation. So this is this may cause the huge loss. Then problem with the availability of the source of energy. Like there are all the location is good, everything is there and the plant is there, but suppose the coal for the thermal plant is not available. Then lack of grid discipline or poor grid management, because grid is the interconnection of the network. So so there are the load centers and which continuously interact with the grid. Then what is the requirement, schedule, proper scheduling is necessary. So lack of grid discipline or poor grid management can also be one of the problem in the transmission network. Then high transmission losses. If the poor equipments are used, if some because of some technical issues, the transmission losses can be there, and which will cause the huge loss in the system. So these transmission losses need to be avoided. So this is the one problem. In the distribution, this is the most challenging area, we can say that distribution sector. So there are some problem, because this is directly dealing with the consumer end, and whatever supply is there, demand to meet that demand, it is this system is working. So inadequate or and aging sub transmission and distribution network is there, because we cannot change the transmission or distribution network frequently, or because this is the huge investment is required for making the complete power system, or for the transmission and distribution of the electrical power. So with the aging of this, what happened, that the it leading to the frequent power cuts, and local failures can be there, faults can be there. Then erratic voltage and low or high supply, the frequency is there. So which will that means the quality of the power is being affected because of this. So which is the challenges, or which these are the problems for the distribution system. So then large scale theft, this is also one of the major problem which cause the higher commercial loss in the power distribution sector. So this theft is to be avoided. So insufficient use of the electricity by the end consumer. If energy is, if power is there, but it is not being utilized, that means insufficient use of there by this. So because we cannot store it, only the battery and some they can store only small power, but for so whatever is generating, it should be used for making the efficient system, or so this can also be there. Then bad power factor also. So poor power factor cause the high losses. I have mentioned in my first session that what is the power factor and how it can affect the system. So so power factor should always be high. It is unity, near to unity, or 0.8 to 1. If it is poor, that means it is more power is it is drawing the more power from the source, and it can affect the whole system. So the day-to-day problems of the consumers, like the hurdles in getting new connections. If somebody is not there, he was not in that in distribution network, then in the remote area, if suppose there is new consumers are there, so then there can be the hurdles in the getting the new connections or enhancement of the load loads. Suppose this distribution is serving to some load, but if the demand is increasing, so enhancement of load is there, so it is necessary to serve that load. So this kind of problem may also come. Then stiff procedures, the procedures are fixed, then if there is no flexibility, then this may also cause problem. Then unfriendly commercial policies are also the the problem for the distribution sector. Now I am coming to the grid. What is grid? So you have heard about this is very familiar word with us, and I have mentioned several times in my session also. So you know that the power system has generating unit to generate the electrical energy which is consumed at the load. So and this energy cannot be stored and has to be consumed at the same instant. Generation is there, it should be consumed, but since the load is not concentrated at one place, and most of the cases it is not possible to have a generator very close to the load center at all the times. So we go for the transmission lines. That means for transmitting the this electrical power for various places, which facilitates the transmission of power from generator to load. So to provide redundancy, the transmission lines are also interconnected. So that means the interconnection of the transmission lines is there. So thus all generation units and the load centers are connected, and as a result grid is formed. Is it clear? So so from the generating consumer, generation to the transmission and distribution and up to the consumer. So this a big network is there, and grid is an intermediary between the generation and load. So this grid is basically the connection of the just generating station, substations, loads through a transmission lines at a voltage level above the distribution voltage level. That means 11 kilovolt or 33 kilovolts. So above this, generally the grid is formed at that level. So distribution voltage, however, is not strictly defined as I mentioned previously. So it is different for different areas. In some distribution system, power is taken from the grid at 33 kV. In some it is taken at 66 kV, and in some it may be of 220 kilovolt. So therefore the grid covers the all mentioned high voltage system down to the level of connection point of the distribution system. So how can you define the grid? If the very standard definition, if I say, then the grid is defined in the Electricity Act 2003 as the high voltage backbone system of interconnected transmission lines, substations and generating plants. So what are the advantages of this grid? It makes the system reliable, it makes the system stable, and there are some economical advantages. So the system is more reliable since we serve the load in more than one ways using grid. as a result, we can say even if one generation unit fails, then the rest units which are connected with the grid, they can share the load. That means the reliability of the system can be increased by using the grid. Then stability, how the stability can be maintained. The system becomes more stable as changes of a fault distributing the whole system become less with this. Then there are economical advantages. In the grid, the cost required is lesser than as a dedicated system, since lesser installed capacity is required as well as lesser spinning reserve is involved. This is what? This is the reserve grid where you are that means you are if you say the what is storing the electrical power, or from where it is being distributed to the different system. So, grid is this. So, and reliability comes with the integrated grid operation for smooth you can say evacuation of the power from the generating station and its delivery to the states periphery. One point is of grid security comes. So, security comes by maintaining the system parameters like frequency, bus voltage, line loadings and transformer loading within the permissible limits. So, these all the parameters which need to be in the limit that to work the system properly. So, it involves the stable and smooth operation of the grid. So, we have discussed all these aspects, that what is the power generation, what is the power transmission, what is power distribution at various voltage levels, how the system works. So, and what is grid, what are the grid reliability issues, grid management. So, all these things have been discussed in this session. So, next session we will discuss other part of this course. Thank you.